Have you ever wondered if our universe holds a perfect mirror, reflecting not just matter, but also time and space itself? Let's take a moment to ponder this. In the realm of physics, symmetry is a fascinating concept. It's like a cosmic rulebook, guiding the behavior of particles and forces. Now, imagine a mirror universe, a realm where everything is reversed, but we're not talking about a simple reflection in space. What if time and matter could also be flipped, creating a mirror image that's not just spatial, but temporal and material too? This is where the concept of CPT symmetry comes in. It stands for charge, parity, and time reversal symmetry. It's the notion that the laws of physics remain the same, even if we reverse charge, swap matter for antimatter, parity, flip spatial coordinates, and time. Imagine if you could flip the universe like a pancake, not just spatially, but also in time and matter. Intriguing, isn't it? Now, let's dive into what CPT symmetry actually means. CPT is an acronym that stands for charge, parity, and time. Each of these terms represents a transformation, a kind of change that we can imagine happening to the universe. Let's unpack each one in simple terms. First, we'll start with charge. In the realm of particle physics, every particle has a corresponding antiparticle. These antiparticles are identical to their counterparts in every way, except they have the opposite charge. So, when we talk about charge transformation or charge symmetry, we're referring to swapping particles with their antiparticles. It's like switching out actors in a play with their understudies, and the plot remains unchanged. Next, let's move on to parity. This term refers to flipping the universe spatially, like seeing its reflection in a mirror. It's about reversing left and right, up and down, front and back. Imagine the universe as a giant painting. Parity transformation would be like viewing the painting's mirror image. The shapes, colors, and patterns remain the same, only their orientation changes. Lastly, we have time. This transformation involves reversing the direction of time. It's like watching a movie in reverse. The characters, the plot, the dialogue, they all remain the same, but the sequence of events runs backward. In a CPT transformation, all three of these changes happen simultaneously. It's as if we take the universe, swap all particles with their antiparticles, flip it like a mirror image, and then run the entire show in reverse. And here's the fascinating part. According to the CPT symmetry principle, even after all these transformations, the universe would still look and behave the same. The laws of physics would still hold true. In essence, CPT symmetry suggests that our universe would look and behave the same, even if we swapped particles with their antiparticles, flipped everything spatially, and reversed the direction of time. You might wonder, why does CPT symmetry even matter? Well, let's dive into this. The significance of CPT symmetry in physics is immense. Consider it as the backbone of the standard model of particle physics. This model describes the fundamental particles and forces that make up our universe, except for gravity. Now, imagine the chaos if this backbone was to crack. CPT symmetry is not just hypothetical, it's been confirmed through rigorous experiments and observations. For instance, studies of mesons, particles that can flip between matter and antimatter, provide compelling evidence for CPT symmetry. But it's not just about proving theories right. Understanding CPT symmetry helps us to unravel some of the most intriguing mysteries of the universe, like the nature of dark matter or the imbalance between matter and antimatter. CPT symmetry is more than just a theoretical curiosity. It's a fundamental aspect of how we understand the universe. So, the next time you look in the mirror, remember, the universe might just have a mirror of its own, a perfect mirror reflecting not just space, but also time and matter.